Greetings, everybody. Thanks for joining the webinar. I'm Paul Green. I run a biogas RNG advisory service after coming out of 30 years in the engineering, construction, and development of biogas plants and an early founder of the American Biogas Council. So I offer these free monthly webinars for their educational value, where we pull in top industry experts to talk about issues of the day in the RNG business. Some of my other projects I invite you to check out are the Biogas book at biogasbook.com and Biogas TV at biogastv.com. Our next event is June 10th, RNG Technical Symposium, so watch out for it. Biogas TV is a fun video platform that tells the biogas story on YouTube at biogas.tv. We recently posted a couple of great videos from earlier this month, so check it out. The Biogas book is at biogasbook.com. It's a platform for written storytelling in the biogas space. There's a good 40-page basics of biogas there. It's a free download. And we're starting to produce voice-to-text interviews with SMEs done as white papers by AI voice-to-text. So today's agenda is here. I'm so pleased with the lineup of 5 industry experts we have on tap for you. CO2 is really new territory for the biogas sector. We're learning so much so quickly. So there's going to be a lot of new ground we're plowing here today. So this event is being recorded and will be stored and available for download on biogas.tv. The slides are going to be on my website at this URL for download later today. We got some of the leading investors, developers, and energy companies, feedstock providers in the US. So interest in this topic is very high. We'll try to get to some questions on the fly. Some of us will maybe be able to stay after the 90-minute presentations if people want to stay on for some Q&A. And if you want to be in touch with any of today's speakers, just download their slides and their contact info will be on that last page. So with that, I welcome Todd Taylor. So Todd is an attorney that has served the bio-based renewable energy community for 25 years, working with developers, entrepreneurs, equipment vendors, and investors to develop, finance, build, and operate RNG, biofuel, and sustainable energy projects. Todd co-founded Advisen Legal after working at a very large law firm as a partner for over 10 years, seeking a more collegial and entrepreneurial approach to being a lawyer. Advisen is a proud member of the American Biogas Council. Todd's a frequent speaker on a variety of RNG topics, including tax financing, equity and debt financing, key contracts, joint ventures, mergers and acquisitions, and more. So with that, Todd, the floor is yours.
Yeah, thank you very much, Paul. And welcome everybody. I'm going to talk about 45Q tax credits. I will say this is like anything tax related, this is a very complicated subject. This is an overview, not in depth. So if you have specific questions about your particular projects, please consult with a qualified expert in the area. And on that topic, Advisen Legal, we are a boutique business-only law firm. We have a particular focus in renewable energy and have been doing it since 1998. We do project development, project finance, all the things that Paul talked about there. And we've done projects over most of the United States, in Mexico, Canada, Caribbean, Thailand, South Korea, Germany, all these different places. So lots of stories over many, many years of doing this. So 45Q, you all probably have some basic idea of what CO2 sequestration out of an RNG process or a train, as we're thinking about, is. But for our purposes for Q, the idea, here, let me start my timer so Paul doesn't get mad with me that I go over, is that the IRA changed the rules a lot, and I don't talk about what the old rules are because they aren't really relevant anymore. For purposes of RNG facilities would be an industrial facility. So the facility has to be capturing at least 12,500 metric tons of CO2 in a taxable year. There are other facilities like electricity generating facilities, if your biogas facility is sending biogas to a genset and you're producing electricity, you might qualify for there. For the higher one, which is actually a higher amount of CO2 that you'd have to be producing. So most facilities that we're talking about in the biogas RNG world are going to qualify if they're going to be able to capture the 12,500 metric tons in a taxable year. And then I talked a little bit about direct air capture. That is a very new technology, very capital intense. They're obviously trying to incentivize that a lot with having such a low threshold for the CO2 capture. Not many projects doing direct air capture, and certainly not the topic of what we're talking about today. So 45Q basics. Again, the IRA was a wonderful law that was passed, a lot of benefits to it. 45Q, already an existing law. What it did, the IRA increased the dollar amount for the ton for carbon capture, storage, and utilization. So if you're doing carbon capture, storage, and saline geologic formations from industrial, which would be RNG and power generation facility, then that's $85 a ton. $60 a ton for carbon capture and utilization from industrial and power generation facilities. RNG facilities would fit there well. That really should, the RNG facility should be at both of the top and the bottom. Although sequestration in saline geologic formations really is geography dependent about whether there's the appropriate geological formations available in your area, unless you're going to hook into a pipeline like a Summit or similar kind of pipelines. But most RNG facility CO2 projects that I'm aware of are looking at industrial reuse, or they're going to connect with like a sustainable aviation fuel or some sort of low fuel project that's separate from the RNG facility. Dollar amounts for direct air capture are obviously much higher. For that, again, they're trying to find ways to encourage this new technology. One of the nice things about the IRA is they extended the deadline for commencing construction until 2033. So as long as your project is beginning construction, and the same rules for beginning construction apply here as they would for the ITC. But as long as you're beginning construction by January 2033, then you're able to receive the credit. And it's a 12-year period for the credit. Now that assumes that you're either taking the direct credit. If you're doing direct pay and you're a for-profit enterprise, you have 5 years for the credit for the direct pay portion of it. So just be aware of that. And we'll talk a little bit about that as well later on. All right. I apologize in advance for this slide. Many of you are likely squinting at it, but this is the IRS rules about utilization of qualified carbon oxide. And these are the rules from before. Well, these are the rules, I should say, from the tax form. We don't necessarily know that these will be the final rules that the IRS will come out with for the new 45Q, but this is what the tax forms that the IRS has about it. And the point of this slide is to show you that utilization isn't simply just capture the CO2 out of the RNG stream, when you're doing the cleanup before you would inject into a pipeline. But you have to then do something with that. If it's sequestered geologically and appropriately, then there's a lot of rules for that as well. But utilization could go into, like the beverage industry. It could go into a lot of industry, dry ice. There's a lot of industrial processes that utilize CO2 hydrogen production, which is heavily incentivized under the IRA as well. Sustainable aviation fuel, methane, or methanol, all of that are processes that use CO2. But there's a lot that goes into analyzing whether or not your CO2 in a capture and utilization scenario gets the credit. And there's this whole requirement for a life cycle analysis. You see, I highlighted there, the LCA must demonstrate that the proposed process results in a net reduction compared to a comparison system. And so, for example, we had a client that was looking at doing strawberries, and they were going to utilize and work with people to do carbon capture out of industrial facilities, pump it in, and enhance the strawberry production in a greenhouse. Well, the question is the moment of time that the CO2 is sitting there in the greenhouse, and how long does that last? And you have photosynthesis occurring there. What really would you get for the value of it? And so in a situation like that, the analysis is likely that you're not going to get kind of a one-to-one value for the tonnage versus the credit, just because it's not sequestered long enough. It's not captured long enough. And so part of that is the analysis that you're having to do when you're trying to create your financial models. You'll have to think about the LCA analysis and how that works. And then remember too, you have to submit the LCA report prior to submitting the credit to the IRS. So the IRS is going to coordinate with the DOE, and they're going to figure out whether or not it applies, if it works, and then the IRS is going to figure out like how much of a credit you're potentially able to get. So keep that in mind as well when you're trying to figure out, how much of that dollar amount are you going to be able to get. So what can you apply when you're thinking about this? The IRS often talks about the train of the equipment, and the train, when we think about that, is all equipment that is necessary to compress, treat, process, or perform other physical action to capture the carbon credit. And so that can be a lot of equipment. The dollar amounts can vary all over the place. But that's the equipment that is used as the basis for being able to claim the credit. And the equipment doesn't necessarily have to be only used for those purposes. There are IRS rulings that look at equipment that have a part to play, but not maybe an integral part, and maybe they're not even essential for any of those, but that they have one of their purposes is to participate in the capture of carbon dioxide. And so in those situations, that equipment can even be part of it. And so just keep that in mind when you're thinking about how you're going to be able to apply for the credit and what equipment qualifies there. Secure geological storage, I just talked about it. Most of that is either local, right on site. You're seeing some ethanol plants out of Illinois and other areas. You see a number of ethanol plants and industrial CO2 emitters that are teaming up with some of the pipelines, like Summit being the biggest one that's left standing, that they're looking at doing this secure geological storage. And you obviously make more money in those situations. But if you're going to do secure geological storage or EOR, then just remember that there are recapture rules, that if there's a leak, the tax credit is subject to recapture. So a lot of times what people are doing is they're buying insurance products to be able to insure against that risk, because I guarantee your investors would not be happy with you if you had to go back to them and say, hey, please give the IRS back all of their money. So this is a huge question, and I'm not going to answer the question that most people have right now, although we're going to toy with it a little bit here. But who can take the credit? So the RNG producer also captures your own CO2. Yep, the RNG producer gets to take the credit. But remember that one entity, very important, one entity cannot take both 45Z or 45V, which is the hydrogen credit, and 45Q. So you have to think about how you're going to do that. So what often people will do is they'll say, well, okay, I'll have one company be my RNG producer with a separate CO2 capture company, but they're affiliates. There's common ownership there. The IRS has rules about that as well, and the result is likely the same. So if you're a third party carbon capture company, so you're an RNG producer, and you're going to do a contract with a company that is doing CO2 carbon capture out of your RNG stream, and now you have to figure out, well, who's getting the credit? Well, the third party is going to get the credit. But right now, we'll talk about later. It's a bit of an open question about whether the RNG producer gets to take 45Z and the carbon capture company also gets to take 45Q. So one thing to think about that may be helpful as these rules are developed, there are prior IRS rulings that allowed the 45Q credit for separate portions of the CO2 capture train that are owned by separate companies. So, and they both would be able to get the credit to an extent that they can verify the life cycle analysis. So it'd be a little bit of an odd situation, but you could imagine if there's 4 pieces of equipment as part of the CO2 capture and storage and reuse, that there could be 4 different companies that one owns each different part of the equipment because maybe it's part of the process. Maybe there's somebody that owns the injection into the well, right? Maybe there's somebody that owns the actual equipment that's taking the slipstream from the RNG for the CO2. And you potentially could have 4 different companies splitting up one credit. It'd be a little odd for that result, but there are IRS rulings that might indicate that that's possible. So as I say here, I'm not necessarily addressing what happens with 45Z or V and Q. We'll talk about that a little bit later. So some common financing structures to think about are direct pay. The great thing about direct pay is if I'm a for-profit company, I get 5 years where the federal government is sending me a check, and banks love that. So from a lending standpoint, that's a really powerful thing. And then the remainder of the 12 years is just a payment stream that comes in, right? And so maybe I'm going to find a tax-based investor that wants to be involved in that, and they'll backstop that. They'll essentially come in after the 5-year period. If I'm a not-for-profit, I'm a tax-exempt entity like a lot of municipalities, they get direct pay for the full 12 years. And we're actually working with a lot of municipalities on analyzing exactly that. But if you take direct pay, you can't transfer. And then transfer and sale, that's another wonderful thing that came up as part of IRA, is the owner of a project can sell a portion of it. You don't necessarily have to do other sort of tax-based structures to be able to get financing. I'm running out of time, so I'm going to speed up a little bit here. I do talk about partnership flip. This is a very common financing structure that you saw pre-IRA, and you're seeing it now as well. It's essentially a tax-based investor, and you create a new LLC or LLP. They get 95% of all the benefits from the project, at least on the tax side. Or more until they hit a certain ROI, whatever the return is, and they can model it however they want, IRR, whatever it's going to be, and then it'll flip. And then after they hit their IRR, then it flips and the ownership really becomes mostly to the developer. And so you can read a little bit more about that there because I don't want Paul get mad at me. One thing to think about, because I know a lot of people are looking at tax-exempt bond financing as part of all of this. If you do it, it will reduce your credit. And it's a very complicated little formula that I had in here before. One of my colleagues said it was almost impossible to read and understand, so I pulled it. But essentially figure out it's about a 15% reduction in your credit if you do get tax-exempt bond financing. A little bit about clean hydrogen and clean fuel that I added here only because I wanted to make sure that we talk about this. One entity is not going to be able to claim 45Q and at the same time 45V for clean hydrogen, 45Z for the clean fuel credit. This is controversial, and I understand it because it's evolving, but until the rules are released, we're pretty much telling people treat the credit as attached to the molecule. So it's two separate entities cannot claim Z and Q or V and Q at the same time. Put aside any RINs, LCFS, anything else like that, right? This is just about the tax credits on the federal side. There are a lot of people that are spending a lot of time trying to figure out how you can separate entity structures to be able to do this. All right, so 45Q versus V, some information about if you're looking at a hydrogen project, do you want to go with the hydrogen tax credit versus the carbon capture credit? Really, it's a question of the size of the project. V is the rules that have come out so far are very restrictive. And if your project does not have a very low life cycle carbon, then you are likely going to have to go with Q, just because you probably won't qualify otherwise. And then Z is a very short period of time. It may be extended, it's based upon kind of the old biodiesel tax credit that was extended time and time again. But right now, Z is only going to last so long. Everyone's assuming that Z will be more profitable than Q, and you can switch back and forth. But 45Q can be direct pay, which is probably better from a project financing, especially from a debt side, than not. There's some information about that. There's my contact information, and I'm done right on time. Paul.
Done, Todd. Appreciate it. And no doubt there's going to be a bunch of questions on that. We have a second for one question that came in here. Does any of the credits apply to carbon fixation, such as biochar production from organic materials, so it's not combusted to CO2?
Yeah, especially if it's sequestered in the ground as like a soil amendment, I think you'll have a better chance of getting a better score, and thus you'll have more tons attributed to your being able to get the 45Q credit. So I think that's, things that are quick in time, right? I mean, your carbon goes into somebody else's product and then is almost immediately released. Likely won't get much of a credit, but things that are like soil amendments through biochar likely have a much higher chance. But these rules are still evolving, and everything's going to be very project specific, and everything's going to be based upon those life cycle analysis.
So I wonder if we hit this topic enough, what qualifies in the utilization category? I know you talked about beverage and dry ice.
Yeah, it has to be something that has a commercial market, right? Which is really not well defined, but you have to be able to show that you have a contract with a third party for a commercial application of the utilization. So dry ice, beverage, almost anything. I mean, they have things in there, like photosynthesis with algae and bacteria. Years ago, I used to do a lot of work with algae and people trying to figure out how to do the Great Green Fleet with the Navy, where you would fuel everything with algae, and that's kind of gone by the wayside. But I think there's a lot there. I would definitely suggest that conversations could be had with a knowledgeable tax person to help you work through that, who can also coordinate with DOE to talk about what technologies, because I think DOE is going to have a big part in figuring out exactly how that works. Because if we just look at, for example, like how Treasury put out some rules about RNG for the ITC, Treasury doesn't know squat about this stuff. So, I know that's not a particularly good answer, but it's an evolving process, and at least it's possible, right? Before, this wasn't really possible. Now it's possible. So, we'll take the W.
Yeah, good time. Thanks so much. We'll let you run. So again, these presentations will be on my website, green-tech.com/events tonight. And so you're going to get an email from me on Wednesday, just confirming that link. So you'll be able to get Todd's slides. And this whole video will be on biogas.tv probably tomorrow. So here we go. Next up, Sam Rushing. Sam is president of Advanced Cryogenics Limited, a 35-year-old CO2 consulting firm, which offers a full menu of CO2 consulting services. Sam's worked closely in technical and market areas with all CO2 source types, including flue gas from power, ethanol, reformer, ammonia, chemical, and biogas. Sam has worked for a variety of CO2 giants like Univar, SEC, and AmeriGas. His practice covers evaluating and developing CO2 sources from all feedstocks, byproduct sources. His work includes defining, developing plant requirements to meet market capabilities, evaluating all costs, requirements, markets, quality and purity, and applications and sequestrations opportunities. So with that, Sam, the floor is yours. Yes.
Okay, good.
Good. All right. We're all set then. Great.
Good afternoon, everybody. My piece is on CO2 industry standards and project economics in the biogas industry. So it's 1:30, I have 15 minutes here. And if you would, for future reference, please contact my website, my phone number, or my email address. My business is evaluating all types of CO2 projects and consultant to virtually everything in the industry. I'd like to feel that way at the very least. Okay, here we go. And then, I'm starting with CO2 quality standards. The standards have been established by trade organizations, along with the input from the manufacturers and major gas companies. The various grades, and normally the grades are discussed or defined as beverage, food, and industrial. U.S. Plant sources from the commercial sector are 49 CO2 sources from fermentation, 23 from ammonia, 19 from natural geological wells, most of which are in Mississippi, 20 from reformers in the oil industry, and miscellaneous sources and so on. That would yield about 111 sources in full here in the States, supplying the merchant market. A couple of them supply EOR, which is not so much merchant. That's another story. But anyway, virtually all of these produce a beverage grade. And beverage grade is a standard in the industry, much of which means that, they use beverage grade for all types of service. It's an overkill for food and industrial, particularly industrial, if you're using it for, say, in a steel mill, for example. But anyway, it's a standard, like it or not. Now, in terms of the grades and so on, these grades have been established by, or should I say defined, by the Compressed Gas Association, otherwise known as the CGA, and the ISBT, the International Society of Beverage Technologists. Everybody likes to make sure they refer to ISBT for beverage. And these specs include a definition of a lot of chemical constituents. I have a slide later on that one. Beverage manufacturers, by the way, do not accept CO2 supplies at present for most biogas sources, particularly if they include fecal matter. It's a matter of perception in the mind of a Coca-Cola or a Pepsi or an Anheuser-Busch, for example. That's black and white. If it's coming from food waste, possibly. But beverage is only 20% of the market, so it doesn't really matter. There's also dry ice, and there's also food and industrial usage. So most, and by the way, we were talking earlier about CO2 going into from ethanol plants going into these pipelines that are either planned or underway. So if a lot of this comes to pass, then it's going to mean less CO2 supply on the markets from ethanol. And of course, ethanol represents, as you can see, the lion's share. And therefore, there is really a need from untapped source types and new sources. So I feel it's really a good time for all of this. Look at biogas. And then I'll talk a minute about the merchant CO2 industry. It has minimal competition. There have been multi mergers among the very giants like a Praxair and a Linde merged, and an Air Liquide and an Airgas merged, and there's really very little competition. There are customers out there that process, that use the stuff directly, that would love to see competition. Linde, for example, among those guys, will not accept biogas sources at present, and none of them will, for that matter, in part because they cannot control it. Most CO2 sources are more likely to consider supplied directly to the processor. manufacturer, and that would yield the best profit margins. So we're not talking about going through a wholesaler. And then, like again, I mentioned CO2 sequestration of ethanol is going to take down very possibly, a lot of sources that would go to the merchant sector. The merchant sector is basically paying like 10 to 20 bucks per ton to the ethanol firms and these other outfits, and like a Lindy, for example, or these guys. And the other side of the coin, if you're going to sequestration, you could get 85 bucks in some cases. So there's a need for significant new production from other source types in the future. Now, I gave you a spec here. Both the Compressed Gas Association and the ISBT have defined CO2 purity or specification in this respect. So CO2 purity calls for 99.9%. This is all ppm volume, unless otherwise stated, such as a non-volatile residues. But these are maximum values here, and this is a minimum value. So, you can see like oxygen, CO, and phosphine, and so on. These are all defined. Of course, hydrocarbons is a big factor, and also sulfur. I have a simple diagram here showing a possible CO2 process, and say we're coming off the digester. We're talking about biogas. Up here we have a membrane, and then down here we'd have CO2 compression and activated carbon, filter and dryer. It's going to be saturated in water, that is a feedstock coming in, raw gas. And then refrigeration adequate enough to turn it into a liquid product for storage or process, or a pipeline, for example, or a gaseous, and gaseous could be a pipeline grade as well. And most pipelines run around 1,700 PSIG, something like that. As I mentioned up here, the most profitable way to monetize your CO2 is sell straight on to the customer, manufacturer, or possibly some sequestration options. And speaking of pipelines, there is a pipeline spec defined by Kinder Morgan, among other majors, that I call kind of a public pipeline. Calls for 95% minimum CO2, and there are limitations on water, hydrogen sulfide, oxygen, so on, to retard bacteria and rust. I had a recent analysis that I produced from an 81 ton per day, I think it's actually 80 tons per day, from a chemical process byproduct. This is just kind of an example of costs and requirements. But anyway, the capital cost for this 80 ton per day plant was defined by one vendor as $3 million, and they use a 15-year amortization, 6% interest to yield this cost here. But anyway, delivery and installation is about 40% of this value. That's a very standard thing to do. When you estimate the estimated laid-in cost for this plant of 80 tons per day from vendor number one is $4.2 million. Power, I was using 6.8 cents per kilowatt hour in this case, and it's about 140 to 160 kilowatt hours per ton power demand for these COP plants. Labor, I threw in around $3 per ton, and cooling water chemicals, $2. Grand total for production costs, in this case, FOB spigot for liquid, $32.01. And this is vendor number one. Now, vendor number two turned out to be 6.27 million. And that's plus low cap sulfur removal. So that's an additional cost. Then all that stuff thrown together with $53.10 approximately. So it's kind of a big difference right there, depending upon who the vendor is and where it's manufactured, and the raw feedstock content and the size and everything else is variable. So all of this has to be analyzed for each location and each type of feedstock. And by the way, for the sake of interest, the cost of freight per ton on average is around $32. And that would be an average US cost for shipping CO2 via tractor trailer. So leading cost, first example, $64. Second example, $85 per ton. So, we're talking about margins from the commercial sector. Say, again, the costs will vary depending upon the feedstock, raw gas, composition, plant supplier, and the size of capacity, of course, all of those drivers. The two examples I used indicated in the $64 and $80 laid-in cost. And, by the way, I was going to say $70 to $100 per ton is a common value to use to the big processors. Should we say a food processor like a Tyson or someone like that? If you're in sourcing from cow manure or chicken manure or something like that, and these guys are very much open-minded in terms of buying product. And there's also a huge amount of dry ice used in the poultry industry and in the beef industry. That's $70 to $100 per ton for the big customers like that. These guys are 5,000 tons per year per plant. Typically, you just sell a part of that, of course. And then if for the small guys that are like 500 tons a day, that would run anywhere from probably $100 to $300 per ton. These are little accounts, but if you piece together a good market to sell into, then the margins could be significantly better. Sequestration value was mentioned by my predecessor. Of course, he's the expert on that, but it's up to $85 per ton. It's a great way to monetize, but obviously you have to pay for the capital equipment. That's the other factor you have to consider. Large food processors are a great target to sell into if you can do that. Or if you have a big manufacturing base for large chemical manufacturing or something of that nature, yeah, EOR is another possibility that can yield, some prices of $70 to $100 per ton. It's less, but you can unload easily. If you want a piecemeal and market, up to $300 per ton. In the end, bottom line, the biogas project developer needs to understand markets, costs, requirements, and related factors in order to yield the best profit margin for their projects. But I feel this is a project type and a source type of the future, given what's happening in the industry. That's my piece.
Yeah, good, Sam. So I think we're all learning about CO2, the CO2 business. And so we're making CO2 from waste gases from many different industries, but I was interested, there's also CO2 wells that you've got a natural CO2 that comes out as kind of pure, you were telling me, right?
Yeah, a lot of it is would meet USP grade by itself with virtually no processing, with no purification. And some of these wells run at a wellhead pressure of something like 1,700 pounds, 2,000 pounds. So they can eliminate the compression part of a CO2 plant and just have refrigeration for making it to liquefy it, and maybe a little bit of filtration, but it's very cheap. They can produce for $20 per ton in some cases, $25.
So again, you're saying as far as market share that beverage has is only like 20%. So if people are trying to find a CO2 offtake, you don't need to get it that clean. There's plenty of off-takers that will offtake that are not that ISBT grade.
Yes, and I would say beverage, don't even fool with beverage, because they're prima donnas as I see them. They really are. It's like 20% of the market. They establish all the rituals and so on, but a lot of that, you have a lot of other markets.
So a great question has come in here that it might take us a while to collectively answer. What is the minimum CO2 flow rate as a rule of thumb that would be considered as a threshold for economics from biogas cleanup for producing RNG? So that's really the question. I think we all might need to jump in on that. So I'm interested, Sam, you feel the cost something like $80 a ton. If we needed to take RNG tail gas and clean the CO2 up, that's the all-in cost, $80 a ton, something like that.
It can be, but it's a function of the constituents and the raw feedstock. That's a big driver, and also the plant manufacturer is highly, a driver in this case, because some manufacturers build their stuff in China and engineer it in Denmark, for example, and then it's going to be worlds cheaper, for example.
Yeah.
I think it needs to be analyzed case by case, and it's hard to just give a minimum threshold. That's really impossible in a way.
And then as we're used to domestic content requirements for the biogas RNG project, but as I've read the CO2 piece, you've got your base credit, you've got your 5x multiplier for prevailing wage, but the domestic content, I haven't seen that there for CO2. Todd, you may even want to jump in here, but so to your point, Sam, about importing CO2 purification from overseas, there's a lot of suppliers that are not American that you see out there.
Yes, there are, and I feel that I love the domestic manufacturers, but sometimes the price of their hardware is so high that it's impossible.
Well, we're going to hear next from one supplier. Japheth is ready in the wings. So I think with that, thank you, Sam. Nice to hear from you, and we appreciate your support. So, Japheth, you nearby here? You with us?
I'm here.
Okay. All right. Very well. So the floor is yours.
Let me quickly get my screen up.
Okay. Very well.
You see it?
I see it. So let me just introduce you. So Japheth is here to talk about CO2 liquefaction equipment. So Japheth Bolsink is a sales manager for Bright Renewables from the Netherlands. Japheth has earned his bachelor's in mechanical engineering, his master's in sustainable energy technologies. So with that, take it away, Japheth.
Thank you, Paul. Thank you for the introduction and also the invitation to be here. So like Paul already said, Japheth Bolsink. I'm working for Bright Renewables. And I want to talk a little bit today about CO2 liquefaction technology that we supply in places all over the world. The content of my presentation is first a short introduction on Bright Renewables, previously also known as Bright Biomethane, but we rebranded our company a little over 2 years ago. Then I want to talk a bit on the CO2 liquefaction technology itself. So how is our technology? How does our technology look like? The product range and references that we've built up to now. Bright Renewables, we have approximately over 150 employees in 2023. Our main office is in the Netherlands, in the east of the Netherlands. And we have local offices in the US, France, Latvia, and Italy. Up to now, supplied close to 200 installations worldwide, mainly biogas upgrading installation. That's what our bread and butter is. We started with that approximately 10 years ago, based on membrane technology, so three-stage membrane technology. And since 6 years, we're also supplying CO2 liquefaction technology. Last year, we had an order intake over Europe and the US over a little over $60 million. So the CO2 technology that we sell. So the CO2 coming from a membrane biogas upgrading system is already typically above 99% pure. We take it off the back end of the membrane system or every other system, so we can also retrofit our CO2 liquefaction technology behind two-stage membrane systems, amine scrubbing technologies, or PSAs. We don't really have we can do them all and retrofit it. So first we will filtrate. First the CO2 will go through an activated carbon filtration step, like the previous presenter already mentioned. It's always dependent on what kind of traces you see in the gas, that you can add additional activated carbon steps to clean out other residues like H2S. We always standard supply a system that that removes VOCs from the CO2 stream. From there, we compress the gas up to 18 bar G, approximately 260 psi. We dry it using a drying step, and get all the water out. And from there, we push the CO2 through the condenser, where the CO2, the gaseous CO2 is liquefied. And we liquefy it with a refrigerant that is based on CO2, so R744. So we don't use freon or ammonia, but we use actual closed loop CO2 cycle as a refrigerant to liquefy our product CO2. Then from the condenser, the liquefied CO2 drops down to through the stripping column, where non-condensable gases are stripped from the liquid CO2 to get the highest possible quality. And from there, at the bottom of the stripping column, the CO2, the liquid CO2, is then pushed into tanks. And we supply all kind of different tank solutions on that horizontal, vertical, and in a lot of different sizes. So the liquefaction technology that we supply here on the right side of this slide, you can see one of our systems we built in the Netherlands. It's a system behind our own membrane upgrading technology, and it enables our client to produce an additional revenue stream by producing food grade quality CO2. That's in this case used in the horticulture industry, so it goes to greenhouses from there. But we also see applications for the food industry, concrete industry, so storing CO2 in refurbished concrete, and a refrigeration industry like dry ice, as already mentioned. These are except for the concrete industry, it's quite known industries that use CO2. A lot of concrete technology is also introduced in the market right now, where we see also a big market coming up, where our clients can bring the CO2. And the future utilizations are, as a few examples, sustainable aviation fuels, e-methanol, and e-methane. And there we see also bigger markets coming up for decentralized use of CO2. The technology that we sell is developed in-house, and we have our own anaerobic digesting plant in the Netherlands that we own and operate, where we tested the complete system. We're unique by using CO2 as a refrigerant, so no freon or ammonia. Especially in Europe, it's the Netherlands maybe even more. It's good to have that, because freon or ammonia are bound to quite some regulations also on the permitting side, for instance. So the market introduction of our current technology was in 2022, and before that we used a different kind of technology for approximately 4 projects. So with adding a CO2 liquefier to your plant, it will improve the carbon intensity score, of course. And also the methane slip goes down, so you can bring back the methane that comes from the CO2 liquefaction as a non-condensable gas stream, and can bring it back to your digester to bring your methane slip to almost zero. We have a containerized setup for plug-and-play installation on site, which means we produce our whole system in our factory, bring it to site, and then we can in 2 or 3 weeks we can install everything. And in 2 or 3 weeks, additionally, we have the plant commissioned, and it's producing liquid CO2. So the advantages of the system, like I already said, it improves the CI score, the lower environmental impact, but also better methane pricing. That's something that's maybe interesting to slightly mention here. I'm presenting it for the US here, but in for instance Germany, there's a link between the CI score and the price of your methane. So you can get a higher price if you have a lower CI score, which means that installing a CO2 liquefier at the back end of your upgrading system, it's quite a good investment, because you earn a lot of it back through your methane sales. Reduction of methane slip, like I said, the extra source of income, of course, so for the sale of liquid CO2 also. And what you also see in other in the European, I haven't seen it in the US yet, but there's also sometimes a need of adding a thermal oxidizer at the back end of an upgrader to burn your methane. And that's not needed with adding a CO2 liquefier. So no methane will be emitted into the air. The product range that we are offering, I put it also in line with the tons per day that I saw in another presentation just now. But we have a very small one, so the mini, 300 to 600 kilograms or 7 to 14 tons per day, metric tons per day. That's really a small one that's equivalent to a system of approximately 200 SCFM of biogas at the lower end. Then we have the compact range is 800 to 1200 kilograms per hour, so 19 to 29 tons per day, all fitted still in a 45-foot container with a separate reboiler skid. So that's the stripping column. That's the 800 kilograms fits behind the 500 SCFM biogas upgrading system. So 500 SCFM of biogas. That's the one that we built most up till now. That's I think also a little bit of the lower limit, as already there was already a question about it, but the lower limit to start with. At least 800 kilograms per hour of CO2 has to come out of the upgrade to make it really interesting. But bigger is always better because the investment of the system doesn't go linear with the capacity. Then there's the medium range, 1500 to 4000 kilograms per hour. We install it in a 40-foot and a 20-foot container. So the compressor will be installed in a separate container. And then we have even the bigger. So the medium is also still a good one to fit behind the biogas upgrading system. After that, the ground is really a big installation that we fit typically behind the carbon capture installation that we also sell. So behind an amine scrubbing technology to remove CO2 from flue gases, but that's not the topic today. The reference that we have installed up till now. So we have a really bunch of them still in Europe. Multiple in the United Kingdom or to come. 5 in the Netherlands. Multiple in Germany, especially because of the incentive there. We have one that's built for the US. That's already built last year. It will go to site hopefully later this year. And that's also the focus that we see now is that the US will also come up with more and more CO2 liquefaction projects. And that's also, like I said before, we have 200 references on all the technologies together right now, of which approximately, I think 170 are in Europe. 30 of them are in the US. So that's a little bit of the split that we have at the moment. So mainly biogas upgrading systems. So with the boost that are coming in the US, I really see also a market coming up on the CO2 liquefaction side. But it's like the previous presenter said, it's really a fine line between where your system is, how big it is, the location. Is there a CO2 shortage or a high demand of CO2 in that region? So you really see that's or also in Europe, that's really an important part of it. You can't truck CO2 very far, so you need to have a good location for your system has to be in a good location to have also a high value for your CO2. So that's one also very important part of the equation by adding something as a CO2 liquefier behind your upgrader. So I have 3 references that I want to show in this presentation. So first one in Tilburg, it's a site that we built last year. So it's 1000 SCFM biogas upgrading system coming from a wastewater treatment plant owned by a municipality. And there we installed the upgrading and the CO2 liquefaction installation. Approximately 30 tons per day is produced there. We did a check there was a sample made of the liquid CO2 a few weeks ago, where the laboratory tested it on what kind of quality it was, and it was was above the food grade quality of of what was requested by our client also. That's what you see by adding the right steps of activated carbon, plus also the stripping column really means that you can get a high quality of CO2 coming from a biogas source. Then a project in Hague is in Germany, same sizing, also 1000 SCFM system, although a bigger CO2 liquefier at the back end. That's typically because in the Netherlands we have low caloric gas, less CO2 to get out of the biogas. So in Germany it's higher. So there we see we could fit a bigger system. Also the same purity reached. So there was an agricultural waste AD plant. And in Helmstedt, also in Germany, it's a little bit of a smaller one, 17 tons per day CO2 liquefier behind approximately 470 SCFM biogas upgrading system. And here you see the tank being hoisted on this place. It was a very big tank, 90 tons storage, so 20 meters high. That was it for now. Thank you for your attention, and my email address is at the back end of the presentation if anybody has any questions regarding this presentation. Thank you.
Wonderful, Yafeth. We have a couple questions while we got a minute. Can you offer any input on how much power does it take to make a ton of liquid CO2?
Yeah, sure. Yeah, it's what we see right now is that our system uses approximately 0.2 kilowatt hours per kilogram, so approximately 200 kilowatt hours per ton of CO2.
Okay, thank you. Do you know the impact on the CI score by putting in liquefaction?
No, I have to do it from the top of my head. It's always a bit of a calculation. Also, the CI score calculation is based on feedstock.
Okay, no problem.
But what we see mainly, if you look at the manure or food waste plant, it's approximately, I think, 30 or 40 grams per megajoule. Okay. So it's quite a significant impact.
And approximately, what do you think the CapEx cost would be on a 50 ton per day liquid CO2 system?
The person that asked that can reach out to me, and then we'll make sure there will be I can send some pricing information on that, or give you a quote on it.
I love that answer. Good. Yafeth, thanks so much. And maybe, if people want to stay on a couple minutes after we're done, we can do some more questions, but we'll let you go.
Thank you.
Thank you. Good to see you. So we've got Brad Peterson on next, and his company is running the only biogas to liquid CO2 system I'm familiar with. So Brad's going to give us some wonderful perspective here as a longtime operator of biogas to CO2. So Brad Peterson is with us. Brad's Executive Vice President of Business Development at NLC Energy. He's been with the company a little over 2 years. Brad joined NLCE to help the company develop and execute on a waste-to-energy growth strategy, specifically in food waste and biomass energy opportunities. Brad came to NLCE with more than 25 years experience running startups, acquisitions, turnarounds, and high-growth companies for private equity firms and a Fortune 50 company. He also spent 3 years as appointed public office for the governor of the state of Utah. Add to that, Brad is the most prolific mountain climber I've ever known. So let's see, how many peaks have you bagged in the past during March, Brad? You've been up, I'm sure, a few times.
Of course, just got back from Norway, but prefer to spend my days in the Tetons and around Utah where I live.
Wonderful, wonderful. So you're ready for action. The floor is yours.
Sure. Let me see. I'm trying to get back. It's kind of, there we go. Let's start here. Okay. Let's see if it's going to stop there. I keep going. All right. Hi, everybody. Appreciate the invitation, Paul. Come share a few things from our experience thus far in this. So I think it warrants just a little bit of conversation about how NLC Energy even got into this business in the first place. We actually, in early 2016, intended on just getting into renewable energy, mostly as a funding partner for an existing operator at the time. They had this particular project just outside of Denmark, Wisconsin, and had proposals for a couple more. We had been in kind of credit tenant financing through the real estate industry for the prior 25 years, and were presented this opportunity. We came in and backed these projects, only to find that the operator that we had actually backed had absolutely no idea what they were doing. And through a series of painful events over the subsequent couple of years, we ended up foreclosing more or less on those assets, taking them over, putting together our own operations team, and proceeding forward. So this particular site is just outside of Green Bay, Wisconsin, a small town called Denmark, Wisconsin, and I'll kind of walk you through that a bit. Let's see if so. Yeah, just a little bit about who we are then today. Since that time, then we put together our own operations team and continued to operate these. So in this particular location, I'll just kind of run through some of these. We have a total of 8 million gallons of digestion capacity, which is both a combination of about 6 million gallons of manure, 2 million gallons of food waste. 100% of those that feedstock is actually trucked in every day and trucked back out. So we're actually one of the first, if not the first, 100% trucked biogas facility approved by the LCFS program. We consolidate manure from about 12 farms. It's about just under 10,000 total head, and brings in about 70 trucks a day into this facility. So that's incoming and then outgoing. During that time, now the reason it's a little bit important to try to understand this is that we somewhat inherited, right, the equipment that came along with this. So in doing so, we did not, I would say, purposefully intend on getting into the LCO2 business, but the way the Pentair skids were set up, that was the way that you could maximize the methane production to the two-stage membrane system. So when we took these over, ironically, originally they were all intended to be food waste. We converted 3 of them then over to manure into those dairies, and kept one specifically for food waste coming out of the Green Bay area, and have really, I would say, as much as anything, left that there so that we could continue to do R&D on food waste, knowing that we wanted to expand into that over time. During that time, then we've added, sensors, throughout the entire AD process, but very specifically inside of that food waste. And we've created some proprietary simulated real-time biomechanical feedstock modeling to help us make sure that we know how to do that. Kind of on a more quantitative, then we produce about 1,200 MMBTU per day. As I mentioned, we have 8 million gallons. Out of that, we can produce about 30 tons. We average 25 to 30 tons per day of LCO2. And from that, we can produce, then we also, because there's a higher value in doing dry ice, I would say, we have installed pellet machines, and now we actually have a block. I'll kind of run through some of those things with you too. Coming out of our food waste, we land up about 14 million gallons of, land up, and we also have third-party decant capacity. So it makes it very interesting in trying to, you got to keep all the gas separate as it comes through, but then it gets put into a single pipeline just on the side of our property. All right, so just a little bit, this is our site. You can see down in the front then, just kind of running through it, we have 4 100-ton tanks that, everything the LCO2 gets stored at. As I mentioned, we are the first, as far as we know, from anaerobic digestion, actually doing ISBT certified gas coming out of it. We have 4 ADs, 3 of which are associated with the manure, coming out. I don't know that there's anything else. And then we installed one house that's got dry ice production that's coming into it. So why don't we keep going down? Yeah, so I guess today we really pride ourselves in just it's not an easy thing. So when we actually took this site over, it was actually shut down at the time. It had been shut down for a couple of months. So we've since, which was in early 2019. So since that time, in turning it back around, we've had no foaming events, nothing significant, and then continued to just produce for the LCFS as well as do these different services, decant, LCO2, and dry ice. So go down to the next. A little bit more about that then too, which is interesting in this regard, because in November we announced this carbon dioxide management agreement outside of Bakersfield, California, where we will be sequestering, ultimately it's just over about 230,000 tons a year of CO2 into the oil fields that are on the Elk Hills site there in a new carbon park that they're building. And we've announced that and proceeding forward on that. We intend on kind of getting through FID by Q3 or Q4 of this year and building that facility out. So more specifically, let's talk about CO2. Why don't you go to the next one? I'll give you, my 2 cents on it. Number one, and I think Sam actually had a lot of good input. I would say most of my input aligns very much with his. Number one is don't let the tail wag the dog. So, every day, our number one goal is to maximize methane production. And, when you start selling LCO2, then your customers just want, you to focus on that regardless. And when you have to shut down the plant to clean things out or to, do some maintenance on it, it has to be very specifically focused on CH4 production. And, you're not there to actually appease your CO2 customers. Customers want consistent supply. So, what we've found is it does vary, just as methane kind of varies depending on the feedstock specifically, not so much on the manure side, but certainly on the food waste side, you have to be very consistent. Sometimes CO2 can come out at 22 tons a day, and sometimes, we've had it at 35 tons a day. All that once you start supplying to a customer, they want, whatever it is that you've committed to. And you can't just say, hey, this week we're down for a week and, next week we'll be back and, I need you to take this. And they just want to be able to contract for what they want going forward. In doing so, customers, and I think Sam alluded to this a little bit with some of the big ones, right? They want transparency into the feedstock supplies. They want to know where they're coming from. They know in our case, because more or less half of our CH4 production comes from manure and half comes from food waste of our 1,200 MMBTU. Very similarly coming in from the LCO2, they want to know what that is. We have, so it creates, it's kind of a challenge in how far, at this point, those buyers want to get back into your supply chain and understand all that stuff. Also cost of production, obviously much higher than the ethanol plants. I would say ours is very much in line with that, $70 to $80 a ton. So you got to be able to make money on top of that. You can go produce dry ice revenue and from the CO2, but it's no small task. It requires a lot of equipment. It's very intensive. It does not require food grade, or it does not require beverage grade certification. You just need food grade certification. ISBT certification is expensive, very time consuming. And one thing I would say I've learned, it's not just you don't get a certificate that you put on your wall. It is a process. And, more or less what's happening is they're certifying a process, and that process is ongoing, and it's never just a one time and you've got it. And just because you have it doesn't mean that your customers even care. They'll push, especially in the AD space, they create their own requirements that exceed ISBT certifications because they want, it's a very new market for them, and they're very skeptical at this point. Number 8, chain of custody compliance is required for every truck that comes in to pick this up. You need to know that those trucks are not going to contaminate the beverage grade certification inside of the tanks when they're unloading. And, ultimately you'll need an extremely qualified team and consultants who are very engaged in this ongoing. Go down to the next. So, I think this is very straightforward, and I would say both, several people have alluded to this, right? Where would you go do this? In my opinion, it's only where there's an opportunity to do it because there's maybe a lack of supply, it's constrained, and therefore there's enough value to actually go warrant it. You've got to be able to get more than $100 plus per ton if you ever want to actually, make any sort of money on it. And even then, I would still be suspect. It's not an easy task to go do. A little bit of production information then, maybe on number 2 here. So we've optimized our 2 million gallon food waste. And from that, you can expect about 20 tons per day if you're just doing from food waste. Obviously, you don't get as much from the manure side. We put together our own website. You can go take a look at it, nlcenergydryice.com. We currently produce 3 and 16 millimeter pellets in 5-pound blocks and have the capacity to produce about 20,000 pounds per day. It's just showing the 5-pound blocks going through. Pretty straightforward. We contracted with Coldjet to be able to do that. So, my key takeaway is do your homework on the market specifically. Make sure that it's really something you want to get into, validate that there is inherent demand in that market. We've already, indicated that the PTCs, it's unlikely that you'll qualify for that. I mean, you actually have to do a fair amount, more than we are, and we're producing 30 tons a day in order to qualify for the PTCs. I think Sam alluded to the fact food grade certification is much easier than beverage grade certification. So if you don't have to, and if there's sufficient demand in the market, you could take on just that. And from what we found so far, there's not a significant difference in the pricing anyway. At least the sales price of it, but on the compliance side, it's much higher. Proximity to potential customers is imperative. Trucking costs, also alluded to $30+ per ton. And sublimation, I mean, if you're doing dry ice, it dissipates over time, and so you can't truck forever. And it's not in my opinion, right? It doesn't lower your CI score. I mean, you're just taking it from one form and putting it back out into the atmosphere in another form. So, maybe it does a little bit here and there through the process, but it's certainly not a carbon negative process.
Thanks, Brad.
Okay.
Appreciate you sharing your operational wisdom. Your
go forward
innovative
with caution.
Yeah, cool. Good. Okay. Last speaker, we've got Mark Pastor with us. Invited Electrokea to join the call today because it's very different, very innovative what Electrokea is doing. So Mark has joined Electrokea to drive deployment of their biomethanation technology in North America. Mark brings over 20 years of experience in business development for innovative early stage technologies and renewable energy, including consulting and sales development in utility solar, battery storage, and waste energy projects. Mark earned his BS in chemistry from SUNY New York Purchase. So thanks for joining us, Mark. Electrokea has really got a novel strategy. So take it away.
Great. So thank you for the opportunity to speak today. I've definitely learned a lot. You put together a great program, and it's obvious that CO2 recovery and utilization is a hot topic. I hear it at all the conferences I go to. I hear it when I'm with customers. And, I'd like to offer another solution for monetizing tail gas CO2 from digesters or other biogas applications. And that is power to gas via our unique BioCat methanation technology. So what I'll talk about today is how you can derive a revenue stream for your CO2 by simply providing the raw CO2 stream from an upgrader, or even providing raw gas. We could also we could take the CO2 stream from an upgrader, or providing raw gas if the project is greenfield. So I want to explain the technology we use for methanation, talk a little bit about the offtake markets for this synthetic methane we produce, and what would be required from the site to accommodate one of our plants. So I look forward to questions, and you can contact me after the webinar to learn more on how you can monetize your CO2 tail gas. So Electrochaea is a clean tech 100 growth stage company. We've been around since 2010, and our technology combines CO2 and green hydrogen to create biocat methane, which is a pure renewable methane. And the value that we create with this, and will create for you, is that you can store renewable energy, you can recycle and get a revenue stream for your CO2, and all this will help to decarbonize the gas grid. We've so far had 3 successful projects, one in Denmark, one in Switzerland, and one in the USA with the NREL. These were all commercial scale pilots, and the project in the USA at NREL is currently being moved to a dairy site in Maine by Summit Utilities, and we're real excited about that. And we've raised over 75 million euro to date from various strategic and financial partners, including Baker Hughes, ENGIE, and others. And we are in the process of scaling up to our 10 megawatt and 75 megawatt archetype designs. We refer to our plant size by the size of electrolyzer capacity, just so that's not confusing to you. So what is this carbon capture and utilization using methanation? So biogenic or waste CO2 are value-added feedstocks, and they could be used to produce methane or e-fuels production. Hydrogen is also a growing business across the US and the world right now. However, accessing that market will require significant infrastructure development and may take many years. So what we're offering here with this methanation process, it's a win-win. One, for those of you out there that are looking to monetize your CO2 stream, and for those investors that are looking to get into the hydrogen space, particularly green hydrogen. So power to gas via biomethanation is the solution to that problem. And I'll explain to you what power to gas is. What this means is you're taking power, which would in this case be green electrons coming from either wind or solar or hydro or other green sources of electricity. And that would be the power side of the equation. Then we look at the sources of CO2. Here we have anaerobic digesters for biogenic CO2, dairies, pig manure, poultry. We have wastewater treatment plants. We also have landfill gases that could be used here, and in industrial space, fermentation processes, ethanol plants, breweries, food production, and then the harder to decarbonize sectors like cement, lime, or steel production. So you take that source of CO2, add it to the power, and then through the biocat methanation process, you will create a synthetic natural gas. So this has a couple of different names. You probably hear it referred to as e-methane. You might hear it as SNG. Whatever the case, you're essentially storing the renewable energy in the bonds of methane. So in that carbon-hydrogen bond, you have that renewable energy. Therefore, you can consider this in a way like a long-term energy storage solution. And the ultimate goal is the hydrogen, which you're making and would be very difficult to sell on its own, now gets to go right into the existing infrastructure of the natural gas grid. So it's the power to gas is that combination of energy, green energy and CO2 to make a renewable gas. How do we do that? So what we're doing here is we're using a biocatalyst that's part of the domain of archaea. It's a 3.5 billion year old single cell microorganism that we've evolved to produce this hydrogen and CO2 reaction instantaneously in our reactor. In this case, we're taking electrolysis to split water. And then we take the carbon dioxide, 1 mole of CO2 plus 4 moles of hydrogen, yield 1 mole of methane and 2 moles of water plus heat. So the nice thing about having this heat being released, it's also released from the electrolysis. It's a 150 Fahrenheit hot water, which can be used to warm the digester. So in the case of the digester, there's really good synergy in that we can utilize the heat and make the process more efficient. The methane is synthesized in each cell of that biocatalyst, of which there's trillions of them in the actual reactor. And what's great about this biological catalyst it's the cells are self-replicating. And so it's a self-sustaining and self-regulating process. It's a simple, scalable design. Unlike other types of methanation plants, this is really just I'd say a hot water vessel with agitation. And as you see here, there's 2 blocks to this technology. There's the electrolysis side, which can be any type of electrolyzer. We really don't care as long as we get green hydrogen. And then in the green block, you see the methanation process. And here, this looks very similar to a typical RNG upgrading plant, but instead of the CO2 separation system, you would actually have the methanation column. So we have the pre-treatment of the inlet gas, and then we have the post-treatment of the outlet gas to bring it to pipeline quality. So that biomethane can go right into the local gas grid. And then the water comes out and it's treated. And depending on the site, there's many things we can do with the water. So looking at the unique features of the technology, again, it's a unique biocatalyst. It's a patented strain. It's extremely robust. And I like to say very efficient, flexible, and responsive. This is all really important, especially when you consider what's happening right now with the IRA and the 45V regulations that Todd spoke about earlier. Now that we know we have to load follow, we have to hourly match, this reactor is highly flexible, able to turn down to 20% of capacity. So therefore, we could easily follow the load of an electrolyzer. Once we can turn this down for days, weeks at a time, and nothing would happen. As soon as you feed it hydrogen, CO2, and nutrients, it will immediately come back to production within seconds and minutes. And we've tested this robustly in the field. It's a selective process. It makes 100% methane at 98.5% conversion efficiency. There's no intermediates. We can take pretty much any quality of CO2 coming in. The only thing the reaction doesn't like is oxygen. So you don't have to go through a lot to clean up. You don't have to compress the gas. We can take it right off the reactor. And it's a simple process, 65 degrees C and about 10 bar. Where we are in our process here for design, we've done our pilot plants, and we just completed our 25 megawatt reactor design, and we're ready. We have process design packages that could go to EPCs right now. Here's a recent press release we're really excited about. We have a 10 megawatt project in the works in Denmark, and we are actively pursuing this project. And so just quickly, our business summary, what we do for you, we will give you a long-term use for your CO2, which will provide a revenue stream. We license our technology to our partners and our owner-operators so we can generate value for you through the sale of the BioCat methane, which is a low CI replacement to fossil gas. Very important, like the other presenter said, location is everything. And same here. The ideal site would have a biogenic CO2 source. We would have a power and gas interconnection in place, preferably in regions where renewable energy is priced well. So we're talking about the Midwest, the SPP grid, the ERCOT grid in Texas, MISO. And we support the expansion of our business models and regulatory policies that recognize the value of low carbon methane. Looking quickly at the e-methane market, it's a strong market. We see that it's growing. There are financial incentives from the IRA. We can stack certain credits. We could get potentially an investment tax credit, as our system would act as hydrogen storage. We provide a solid offtake market for investors in methanation projects, strong interest from natural gas utilities with decarbonization goals, and also from the voluntary market, of which we can sell into our attributes. And really, interestingly enough, we're looking at potential sales into European and also other North American markets. So in conclusion, this e-methane provides a unique opportunity to monetize CO2 value add streams while allowing hydrogen unlimited access to the gas grid. The e-methane market is strong and growing globally. We believe this will provide surety for investment, and we provide an opportunity for renewable energy developers to capture value from curtailed or maybe soon to be retired wind or solar assets. So the BioCat methanation project provides a case for a long-term PPA for these developers. And lastly, we help in finding the ideal site and power and offtake commitments and provide assurance and financial backing for first-of-a-kind commercial installs. In a way, we're acting like a pre-developer to put these projects together. So thank you very much for your time, and I look forward to any questions. Please reach out after the webinar.
We'll give you one question here, Mark.
Yeah.
For green hydrogen credits, the new 45V credits require green power be new and incremental green power, not from existing wind, solar, hydro on the grid. Can you comment?
Yeah. So that's one of the challenges. We've been working very closely with several large renewable energy developers who are looking at repowering or looking at different strategies to meet that additionality requirement. And we know that we will be running lower than the 8,000 hours that we would like to run, but we've done the economics here, and we believe the offtake market is strong enough that these projects will pencil, even with those restrictions on the 45V.
Good. Okay. Mark, thanks. So we'll wrap it here. So everybody, thank you for sticking it out, all 166 of you that stayed till the end. Wednesday, you're going to get an email from me with the links to download the full video and the PowerPoints. So just want to say thanks to the presenters. And if this topic was of interest to you, don't hesitate to circle back with me. We're doing these webinars very regularly. So with that, we'll call it good. And thanks everybody for attending.